Started. You have completed the frequency reviews. And today we are going to start the next point, that is channel assignment strategies. Channel assignment strategies is nothing but what there are mainly two types of strategy we are using in this. One is fixed channel assignment strategy and second is dynamic channel assignment strategies. What is the meaning of this channel assignment? You are going to allocate a particular channel to the particular user. We are going to allocate a particular channel to the particular user. What are the problems we have created in the previous years, that is 1956 and 1970s, and what are the nowadays we are going to get the many number of channels for, that is for a channel assignment strategies. What is the main aim of this channel assignment strategy? That is to be goal is to minimize interference and maximum use of capacity. Interference is nothing but what? There should be a no interfering, that is there should be a no collision between the two signals. That has to be minimized by this channel assignment strategy. If you minimize this interference, collision between the two signals, that has to be increase the capacity of a particular system. So that function has to be done by channel assignment strategies. Okay, there are mainly two types of channel assignment strategy. One is fixed channel assignment strategy and second is dynamic channel assignment strategy. You have to write down these two assignment strategies. One is fixed channel assignment and second is dynamic channel assignment strategies. Okay, the name itself will tell you the answer. That is, fixed channel assignment is nothing but what? Whatever the channel assigned for a particular user or whatever the channel assigned for a particular cell are fixed. Whatever the channels assigned for a particular user or a particular cell are fixed. That is known as a channel assignment, that is fixed channel assignment. Okay, the channels are divided in sets. The channels are divided in sets. What is fixed channel assignment strategy? Whatever the channels allocated for a particular cells are permanently allocated. It is not a changed. The stable channels has been allocated. Okay, if you want to make a call, if a particular cell has been allocated for a particular cell A1, cell A2, cell A3. These are the three cells are present, A1, A2 and A3. Okay, cell A1 is having 6 channels, cell A2 is having 7 channels, cell A3 is having 8 channels. Okay, if the person or the user located in cell A1, if the person or the user is located in cell A1, the only 6 channels are present. Only 6 channels are present in A1. Okay, if the channel is available out of 6, if the channel is available, then only the call will be connected. Then only the channel will be assigned to that person. All the 6 are busy. All the 6 channels are allocated to the other users. If he is not getting any channel, the call will be disconnected. The call will be disconnected. This is what the meaning of fixed channel assignment. But one more point is there, how to get a particular channel, that is he has to borrow. He has to take the channel from the other cell. He has to take the channel from the other cell. Once the call has been over, the channel has been returned back to that cell. What it means? If 7 channels are available in A2, 6 channels are allocated, 1 channel is free, 1 channel is free in A2, but user present in A1 wants to make a call. User present in A1 wants to make a call. He has to take that channel from A2 cell. No channels are available in A1, but user wants to make a call from A1 cell. But the channel is available in A2. 1 channel is available. He has to borrow that channel from A2 cell. Once the call has been over, that channel has to be returned back to that particular cell. That channel has to be returned back to that particular cell. This is the process is called as a borrowing process has to be done. He has written same thing in this. A set of channels is permanently allocated to each cell in the network. Okay, whatever the channels allocated in the particular cells are permanently, not variable. Okay, If you allocated the permanently, it is going to reduce the co-channel interference. The next point, any call attempt has to be done if the channels are available, then and then only the call will be connected. Otherwise, the call will be disconnected. Another process is there, that is what the borrowing scheme. उधारी लेते हैं ना, that is what borrowing. उधार लेने का बाद में जब आता है तब वापस दे देने का. That's it. That is what the fixed channel. You has to take the channel from the other cell. Once the process has been over, once the calling process has been over, that channel has to be returned back to that particular cell. That process is called as a borrowing process. This is what the concept of fixed channel assignment. Fixed channel assignment is nothing but what? The first point, the fixed channels are allocated to the permanently allocated to the particular cell. Okay. If any call attempt has to be made, the channels are, if the channels are available, that channel has to be allocated to the requesting user. Then and then only the call will be connected. Otherwise, call will get disconnected. Next point, the one more process is there that has to be borrow the channel from the other cell if the channels are available in that other cell. If the channels are available in other cell, then and then only you can take the channel from the other cell. Okay. Once the calling process has been over, that channel has to be returned back to that particular cell. That is called as a fixed channel assignment strategy. Second type is dynamic channel assignment. What is dynamic? That is unstable, variable, dynamic channel. There are many number of channels. Available in particular cell. If no channels are available, immediately you can take the channel from the other cells. Immediately you can take the channel from the other cell. He can't use any borrowing process. He has to send the request. To the particular MSC. MSC will going to allocate a particular channel. That is what channel. Voice channels are not allocated to any cell permanently. It is a dynamic. The channels allocated to the particular cell are variable, dynamic, not permanently. Okay. All the channels are kept in a central pool, are assigned dynamically to new call as arrive in the system. Who is going to request the service? If you want to make calls for multiple times, the multiple channels has to be allocated like this. At any call, the request has to be made in this dynamic. For any call, the request has to be sent. That request has to be gone from the first you are using your mobile, from mobile station to your base station, that is your tower, BTS. And that tower has sent that request to the BSC, that is base station controller is present in that tower. Base station controller. It has to control all the requests. It has to control all the requests. Who is going to request a service? Who is going to make a call? Who is going to receive a call? All the information, all the request has to be done this BSC, that is base station controller. That BSC has sent that request to the MSC, mobile switching center. That mobile switching center is going to allocate particular channel to the requesting user. Each time the call request has been, the service base station has sent request to MSC. MSC is going to allocate a particular channel to the requesting user. That has to be done in this dynamic channel allocation. Okay. Till the end of the conversation, till the end of the communication, there should not be any disconnectivity of the call. That has to be taken care by this MSC. Remember this, mobile switching center. MSC is mobile switching center. The same thing has to be taken place. This is going to reduce co-channel interference, and it is going to increase the signal strength and signal to noise ratio. It is going to increase the strength of the signal and signal to noise ratio, that is SNR. This is what the concept of channel assignment strategy. One is fixed channel assignment strategy. Second is dynamic channel assignment strategy. Fixed is nothing but channels are permanently allocated. Dynamic is nothing but Channels are not permanently allocated. The channels are variable. Channels are variable. For a multiple calls, the multiple number of channels. Just you should remember this point. Next, point for unit number 1 is handoff. Handoff strategies. Handoff strategy. What is an handoff? Handoff is nothing but what? The one cell is going to hand over. The one tower is going to hand over the next tower to the particular channel. Tower to tower, you are crossing. Whenever you are moving on the highways, you are going for a longer distance communication. If you are in a call, you are crossing many number of towers. You are crossing many number of towers on the highways. At that time, the channel has to be shifted. The channel has to be shifted. That channel shifting channel has to be taken care by this MSC. He has written the same thing. What is handoff? When a user moves from one cell to the other cell, he is changing the locations. He is changing the particular locations, particular points to keep the communication between the user pair. Communication is nothing but the call is going on from one end of the user to the other end of the user. Keep the communication between the user pair. The user channel has to be shifted from one base station to the other without interrupting the call. Interrupting is nothing but without disconnecting the call. That is called as an handoff. Next, when a mobile station moves into the another cell, while the conversation is still in progress, you are speaking with other person, the MSC automatically transfer the call to the new FDD channel, that is frequency division duplexing. Number of frequencies has to be available for different channels. That is to be duplexing without disturbing the conversation. This process is also called as handoff. Means what? Whenever you are moving on the highways, you are crossing number of base stations, you are crossing number of towers. At that time, you are going to change the number of channels. Those channel assignment strategies has to be taken care by the MSC. MSC is going to observe everything that there should not be any disconnectivity in between that. Okay. And what are the operations of this handoff? It has to be identify the new base station. You are crossing number of base stations. Those base stations is having different channels, and those channels has to be allocated to you. That has to be identified this new base station. And the voice control and controlling of this by communication has to be taken care by the handoff. This is one of the basic block diagram of handoff. You are seeing two cells in this. You are seeing the two cells. The shape of cell is hexagonal. The base station 1 is here. Base station 2 is here. Cell 1 and cell 2. Where there is a one vehicle is seeing. You are seeing two towers in between. Cell 1 is having one tower. Cell 2 is having one tower. There is a vehicle. Once the vehicle is reached to the edge, the corner of a cell A, it has to be starts a handoff. He is going to cross my location, he is going to reach your location. He is going to cross my location, he is going to reach your location. So you have to allocate a particular channel to this person. So you have to allocate a particular channel to arriving person. That has to be taken care by this handoff. Cell 1, cell 2, very small fraction of seconds. Handoff starts, handoff ends. हमको पता नहीं चलता है कैसे हो जाएगा. We don't know how this handoff has happened. Within a fraction of seconds, you are getting multiple number of channels. That has to be taken care by this handoff. This handoff process is mainly depends on the power margin. It is mainly depends on the power margin. That power margin has to be assigned by del. That is, power margin has to be assigned by del. Okay. The del is equals to PR of H minus of PR of min. You have to write this. They will ask you for MCQ. They will ask you for in the MCQ. They will ask you for a definition of handoff, and the power margin is del is equals to PR of H minus of PR of min. What is PR of min? H. That has to be a slightly stronger level. The strength of the signal is high. PR of min, the strength of the signal is low. That is of minimum. So that is what that handoff process has to be taken care by this power margin. The power margin should be always a medium. It has to be taken care by this. Almost all the conversation, it has to be taken care by almost all the communications that has to be done by this power margin. Okay, del is equals to PR of H minus of PR of min. If the del is too small, if the strength of the signal is less, you are having the network signal is less, you can't connect the call. You can't connect the call. That is what PR of min. That is enough time to complete the handoff. Whenever you are moving, your network is decreased, your disconnectivity, calling disconnect will be happen. That has to be PR of min. If it is del is too high, your loss, the power loss margin is going to loss. Power margin is going to loss. Though that is to be taken care by this, the power margin should be at the minimum level. The power margin should be at the minimum level. That has to be taken for care by del is equals to PR of H minus of PR of min. PR of H is maximum level, PR of min is minimum level. Next, what are the priorities of handoff? The main priorities of handoff is what? Whenever you are in a communication, you are speaking to other person, but somewhat due to some network issue, the call has been disconnected in between. Okay, the network issue, that call has been disconnected. That has to be taken care by this handoff. If the disconnectivity call has to be taken care by this handoff, again to connect that call, the channel has to be allocated, the main channel has to be allocated for this connectivity of this person, disconnectivity person. That has to be taken care by handoff priority. The dropped call is considered a more serious event than the call blocking. Okay, it has to be allocated a particular channel who has disconnect the call in between. The fraction of the total available channels in a cell is reserved only for a handover request, because mainly many of the millions and trillions of people are nowadays moving from one location to other locations. Okay, for that, there has to be stored, many number of channels has to be stored for this handover request. So it is going to carry out is going to reduce the traffic in the particular signals. Okay, and it reduces the rate of handoff failure. The many 2 to 3% of the handoff process will get failure. Other than 98% will not get any failure and disconnectivity of the call. That is the main priority of handoff. Next is, there are two words actually, handoff and handover. When you search, if you see in the book, you are observing two names, two words, that is, one is handoff, one is handover. But the word of handover can be used in India and Pakistan. The handoff should be used in United States. But nowadays, the India is also, nowadays we are also speaking this, the word as handoff also. You can call both, that is handover or handoff. There are mainly two types of handoffs. There are mainly two types of handoff. One is hard handoff, one is soft handoff, or hard handover or soft handover. Both the words are same. Remember this, write down this, the types of handoff. Types of handoff is hard handoff or soft handoff. What is the meaning of this hard handoff? There is one sentence that is, hard handoff is break before make. Hard handoff is break before make. Soft handoff is make before break. Have you understood the meaning of this hard handoff and soft handoff? Break before make. Soft handoff, make before break. See the meaning of this. First, you have to break the previous connection. You have to break the previous connection, and after that you can make the connection of next connection. Break the previous connection, next you have to connect the next connection, that is hard handoff. That has to be used in second generation and fourth generation. Soft handoff, make before break. Soft handoff is make before break. First you have to connect the next connection, next you have to break the previous connection. Getting the point? Make before break. First you have to connect the next connection and you have to break the previous connection. That has to be used in 3G and 5G. We are using for, and 4G also we are using soft handoff. That has to be, whenever you are in a communication, you have to connect first, next you have to break it. That has to be happens nowadays. That is how soft handoff. Hard handoff is break before make. Soft handoff is make before break. And other handovers or other handoffs have to be taken place over in this. One is intra BSc handover, INTRA. Intra BSc handover, inter BSc handover, inter MSc handover. In India, total 23 to 24 MSCs are there. That is mobile switching centers. MSC is nothing but what? Mobile switching centers. In India, total 23 to 24 MSCs are present. All these MSCs are connected with each other. There is a communication between each MSCs. What happens? I will tell you this handover. Intra BSc. See the diagram? Intra BSc, inter BSc, inter MSc. Okay? There is a vehicle. You are driving a car on the highways. The BTS 1 to BTS 2. You are crossing a number of BTS. I am taking only the example. You are crossing number of towers on the highways. BTS 1 to BTS 2. It has reached. The BTS has been changed. BTS has been changed, but BSc and MSc remains same. Both the BTS are connected to one BSc and BSc is connected to MSc1. This type of handover is called as intra BSc handover. Intra BSc handover. BTS has been changed. Base station controller remains same. Mobile switching center is also remains same. This type of handover is called as what? Intra BSc handover. Again, the vehicle is moved from BTS 2 to BTS 3. Next, BTS 2 to BTS 3. That is, BTS has been changed. BTS has been changed. BSc also changed. BSc also changed. But MSc remains same. See the connection. BTS changed. BSc changed. MSc remains same. This type of handover is called as inter BSc handover. Inter BSc handover. Again, the third BTS is moved to the fourth BTS. Again, the same point you are getting. BTS changes, BSc remains same, MSc remains same. Again, the intra BSc handover. Now, whenever you cross from fourth BTS to the fifth, that is from last, BTS also changes, BSc also changes, MSc also changes. Getting the point? BTS changed, BSc also changed, MSc also changed. This type of handover is called as inter MSc handover. Means you cross the boundary. You have crossed the boundary of Maharashtra. You reach to the Karnataka state because you are changing the states. You have changed the states from Delhi to Punjab, Punjab to Haryana, Haryana to Kashmir, like this. Once you have crossed a state, once you have crossed the boundary of a particular location, that time you are crossing everything. That is, you have crossed the BTS also, you have crossed the BSc also, you have crossed MSc1 to MSc2. You are in MSc1, you are in Maharashtra, you gone to Delhi, that is MSc2. So this type of handover is called as inter MSc handover. This type of handover is called as what? Inter MSc handover. Remember this. Next, this is not in your syllabus, but for a knowledge point of view, you have to remember this. Handoff in different generations. Already we have studied the generations. First, First generation, that is 1G. Second generation, that is 2G. Third generation, that is 3G. We are using these three generations in different generations. That is 1G, that is first generation, is also called as a network controlled handoff. Network controlled handoff means you are using the Nokia set previously. Okay. Nokia set has to be, everything has to be controlled by the network. Everything has to be controlled by the network. That is switching center. Switching center has to be controlled. Okay. For that, the available channels are very less. The available channels for that particular network is very less. So it takes more time for the handoff and power margin required is very high. So he has written in this, the first generation handoff is also known as or also called as network controlled handoff, NCHO, network controlled handoff. For a handoff, it requires a time for 5 to 10 seconds. For a handoff, it requires a time for 5 to 10 seconds. And the power margin required is of 6 dB to 12 dB. Power margin, that is del. Power margin has to be assigned by del. The power margin has to be 6 dB to, that is 12 dB. This is what? A 1G. 1G is also called as network controlled handoff. The total handoff required, the time required for handoff is 5 to 10 seconds. And the power margin for 1G is 6 dB to 12 dB. Second, we move from 1G to 2G. 2G is called as mobile assisted handoff. Mobile assisted handoff. You have to control by in your mobile itself. This mobile assisted handoff is going to decrease the particular handoff time. That time is nothing but that is from 1 to 5 seconds. That is from 1 to 5 seconds, and the power margin del is of 0 to 5 dB. Again, the power margin is required. Whatever the power required for this second generation is decreases, that is of 0 to 5 dB. And for third generation, this type of handoff is called as mobile controlled handoff. Mobile controlled handoff, in a fraction of seconds, the handoff has to be taken place. That is of 100 milliseconds. 100 milliseconds, that is of 10 raised to minus 3, 0.1 milliseconds, or of 0.1 second, 0.01 second, that is. And the power margin, that is del, is of 20 dB per milli. 20 dB per milli. So it is going to increase the particular quality of service. It has to going to increase the quality of service. This type of handoff is called as different type of handoff. One is first generation. Write down first generation, network controlled handoff. For a second generation, mobile assisted handoff. Third generation, mobile controlled handoff. The time required to complete the handoff for first generation is 5 to 10 seconds, and the power margin is 6 dB to 12 dB. For second generation, mobile assisted handoff, and the handoff required is 1 to 5 seconds, and the power margin is of 0 to 5 dB. Similarly, for 3G, it is mobile controlled handoff. The time required is of 100 milliseconds, and the power margin is of 20 dB milli. This is what the concept of handoff strategies. Next point, interference. Interference and system capacity. What is an interference? I already told you. Interference is nothing but interfering with two signals. Two signals are going to collide with each other. That is called as interference. Where we are going to have this interference signals. The interference is mainly occurs when two base stations are operating at the same frequency. The interference is mainly occurs when two base stations are operating at the same frequency. At that time, this interference will be happen. And interference is also occurs, that is a crosstalk between two signals. Means क्या हो जाता है, आप किसी को कॉल किया, आपने कॉल किया, कॉल करने के बाद कॉल एक्सेप्ट हो जाएगा, पर उनका दूसरी किसी और का वॉइस आपको सुनाई देगा, आपका वॉइस उनको नहीं सुनाई देगा, किसी और का वॉइस, कोई भी किसी के साथ बात करते रहते आपको उसका वॉइस सुनाई देंगे, दैट इज कॉल्ड एज ए क्रॉसटॉक. क्रॉसटॉक हो गया, दैट इज इंटरफेरेंस. द सिग्नल हैज बीन इंटरफियर. आपको बहुत बार एक्सपीरियंस हुआ होगा, आपको कॉल किया होगा, किसी और का वॉइस आपको सुनाई दिया होगा, दैट इज व्हाट interference. Crosstalk has been happens, that is what interference has been happens in a crosstalk has been came up. And this interference is also occurs in the urban areas because the population is more, number of base stations are more, and this base station is going to have a many number of channels, but in between the weather conditions, due to bad weather conditions, it is going to happen interference. So these are the interference points of view where the interference is going to happen. The one cell is having the same frequency and the other cell is also having the same frequency, interference will be happens. And both the base stations are operating at the same frequencies, interference is happens. Interference is also happens when the crosstalk between the two signals. Interference is mainly more in the urban areas because the greater density of mobiles and the base stations. Interference has given one definition over here: when two or more electromagnetic waveforms, to form a resultant wave, that is the output wave, in which the displacement is either reinforced or cancelled. At the output, it may get the strengthening signal or it may get cancelled due to some of the interference of the signal. Two signals are moving, it has to reach at the output, but at that time one more signal is going to interfere with these two signals. One more signal is interfering with these two signals, that is to be cancelled out. That has to be happens in this interference. Okay, if the interference is less, you have to increase the capacity of a system. If the interference is less, you have to increase the capacity of a system. If the interference is more, the capacity of system will be decreases. If the interference is more, the system capacity will be decreases. If the interference is less, the capacity of a system will be increases. There are mainly two types of interference. One is co-channel interference. Second is adjacent channel interference. Write down this. Two types of interference. One is co-channel interference. C-O-C-H-A-N-N-E-L. Co-channel interference. Second is of adjacent channel interference. Co-channel is nothing but what? In co-channel interference is less because the distance between the two signals are high. Distance between the two signals is more. A1 and A2. A1 and A1, these two cells are located at far away distances. This is what co-channel. Adjacent channel, the side-by-side cell. It is going to create a interference. This is what the first point for this is co-channel interference, that is CCI. In short form, it is called as a CCI. Co-channel interference has to be taken place. The cells where the same set of frequencies is used is called as a co-channel. Means I already told you in the cellular concept that the frequency used in one cell, the same frequency can be reused in other cell with the sufficient distance, which is called as a frequency reuse. That frequency reuse concept can be used in co-channel interference. The concept of frequency reuse can be used in co-channel interference. Means increasing frequency reuse also increases the interference, which decreases system capacity and service quality. The cells where the same set of frequency is used are called co-channel cell. Co-channel interference is a crosstalk between two different radio transmitters using the same radio frequency as in the case of with a co-channel cell. Already told you there is a crosstalk between happens. Not that much of percentage, 5 to 10% of we are going to get this crosstalk. 90% we are getting the calls. We are receiving the call, we are making the calls. Okay. This crosstalk is also, this co-channel interference is also happens because of the bad weather conditions, poor frequency planning. Bad weather condition is nothing but what? You are not receiving the signal in your TV because of bad weather condition. Mainly in the rainy seasons, your TV is not able to accept, not able to accept the particular signal. Why? Because of bad weather condition. This happens the reason for co-channel interference. And this co-channel interference is mainly depend on the radius of a cell, that is R. CCI, that is co-channel interference, is mainly depends on a radius of a cell, that is capital R, and the distance between the two interfering cells, that is from two cells. I told you there is a distance will be maximum. The distance will be maximum in co-channel. Okay. If the cell size and the power transmitter at the base station are same, then the CCI will become the independent of the transmitter power and depending only on the radius of the cell, that is capital R, and the distance between the two cells, that is capital D. That has to be calculated by distance between two cells, that is D divided by R, radius of cell, that is R, radius of cell, that is R. This is very, very important. That is, you have to calculate how much is the radius of a cell. Depending on that, you have to reduce the particular cell. Okay. That has to be calculated by frequency reuse ratio. How to calculate this? Frequency reuse ratio has to be taken care by this Q is equals to D divided by R. Q is equals to D divided by R is equals to square root of 3N. What is of N? Capital N. Anyone?
Cluster.
Oh, good. The capital N is of cluster, size of cluster. What is the definition of cluster? A group of cell having a disjoint frequency or a non-overlapping frequency, that is called as a cluster. A group of cell having a disjoint frequency or a non-overlapping frequency, that is called as a cluster. So that is, this cluster size is mainly depends on this frequency reuse ratio. Why? Because we are multiplying a number of clusters. If you are multiplying a number of clusters, we are going to increase the system capacity. If you are going to increase the system capacity. So the frequency reuse ratio, that is Q is equals to D divided by R is equals to square root of 3N. This is what one of the diagram he has given. D minus of R and D plus of R. He has mentioned D minus of R, D plus of R. The mobile is at the nearest to the cell. Mobile is at the far away from the cell. Mobile is at the nearest to the cell and the mobile is at the far away from the cell. This is what concept of co-channel interference. And second is adjacent channel interference. This adjacent channel interference is nothing but what? A side by cell. Adjacent channel is what? Nothing but a side by cell is going to get interfere with each other. There is no that much of interference happens in adjacent channel. Why? Because the different frequency bands are using, the different channels are using, but the third person is going to enter in this adjacent channel. The third person is going to enter in this adjacent channel. Interference is going to happen. Interference is going to happen. That is going to calculated by signal to noise ratio or signal to interference ratio. signal to interference ratio, that is S by I is equals to 10 raised to minus of n. N is the number of channels available in this. Okay, we'll see in the next lecture for a second type. Today we'll stop here and be prepared at any time, or one day I will take you a seminars on the covered topics. You have to choose any of the topics. It's left to you, but be prepared. I will take you the seminars next Wednesday, coming Wednesday. Okay, be prepared. Any of 10 or 15 have to prepare the topics. How much have covered till Tuesday, coming Tuesday. You have to explain that point for 5 to 10 minutes. Okay, be prepared. We are going to start our basic turbo mass, that is based on the tutorial seminars and the submission of tutorial PDFs and all. So be prepared for 1 week 10 to 15, second week next 16 to 25, next for next. Okay, be prepared from 1 to 15. Don't say I'm not prepared and all. You are losing your marks. Keep in mind. Your attendance